This presentation will review the Georgia Standards of Excellence for MBT4, which states that students will fluently add and subtract multi-digit whole numbers using the standard algorithm. Second and third grade students explored computation within 1000 by using a variety of concrete models and methods based on place value, properties of operations, and the relationship between addition and subtraction. These methods are then generalized and extended to larger numbers up to 1 million in fourth grade. Common addition strategies use place value understanding to decompose add-ins. Students create partial sums by first adding like values or by adding on with friendly numbers. Students can also use compensation by adjusting one or more add-ins to create friendly numbers. For example, when adding 194 plus 348, students can add 6 to adjust the first add-in to 200. The sum can then be decreased by 6 to get the final answer. Adjusting one or more add-ins to create friendly numbers can be an efficient and effective way to add. Many subtraction strategies are also based on place value understanding. In this example, students decomposed the subtrahend in order to count back to find the difference. And in this example, the student uses addition to count up to find the difference. Students can also keep a constant difference by adjusting the numbers to create friendly numbers. For example, 80 minus 27 is adjusted to rename the problem as 83 minus 30. The minuend and subtrahend are adjusted by the same amount in the same direction. Strategies such as these encourage the development of true number sense with no need for regrouping. Students naturally transition to an abstract standard algorithm in fourth grade after being exposed to multiple strategies and concrete base 10 models. Using concrete models to compose and decompose numbers is the key and lays the foundation for regrouping. For example, 100 2 tens and 4 ones is the same as 12 tens and 4 ones, as well as 11 tens and 14 ones. All of these examples show 124 represented in different ways. A common misconception among students is thinking that a new quantity is created when regrouping. 8 tens and 13 ones is still 93. To reinforce decomposing numbers in different ways, students can explore the task making sense of the algorithm that appears in Unit 1 of the Georgia frameworks. Students are presented with problems such as, to work out 856 minus 138, Jane rearranges 856 as 800 plus 40 plus 16. Why does she do this? Throughout the task, students are able to use models such as these place value disks to justify and explain their thinking. Once 856 is decomposed into 800s, 4 tens, and 16 ones, students can easily take away 138. In this next example, the student used digiblocks to solve 856 minus 168. The student first decomposed 100 into 10 tens and then 110 into 10 ones to discover that 856 is the same as 700s, 14 tens, and 16 ones. To learn more about the role of standard algorithms in the standards, please review the article that is available below this presentation. In the past, teaching the standard algorithm has students memorize the steps rather than understand and explain them. Steps that can be generalized and lead to a standard algorithm should be explained with visual models. When connecting computation strategies to the standard algorithm becomes much more than just a list of isolated steps and procedures to memorize. While helping students make sense of the standard algorithm, it is important to incorporate a variety of real-world tasks and puzzles. This puzzle, for example, has multiple possible starting points that allow students the opportunity to discuss and share strategies while explaining why their strategy works. In this population puzzle, students had to use both addition and subtraction to find the missing numbers. So how did you know the population of Atlanta?
Well, I knew the population of Sandy Springs was 105,330, and I took that number and added it to this, and I got 463,878.
So if Columbus and Athens have a combined population of 317,293, how did you know Athens' population if it wasn't there?
Well, I knew the Columbus population was 200,579, so I thought about it for a minute and I realized I had to subtract. So I took this number and I subtracted 200,579 from 317,293, and I got the sum of I got the difference. Sorry, I got the difference of 116,714.
Having students explore the standard algorithm for addition and subtraction should include much more than a series of isolated problems to complete. Open-ended problems such as this allow opportunities for students to explore different situations and be involved in rich discussions as they compare their work with peers. Students can also create their own problems with tasks such as Tell Me a Story. After choosing digit cards to create two numbers, students write their own addition and subtraction story problems to solve.
On Monday, we sold 865 tickets. On Tuesday, we sold 182 tickets. How many tickets were sold in all?
There are 1,047 students at my school. If there are 182 fourth graders, how many students are in the other grades?
With appropriate foundational skills based on place value understanding, fourth grade students begin to understand why the standard algorithm works. But is the traditional U.S. algorithm always more efficient? When subtracting across zeros, for example, the standard algorithm uses lots of procedural steps, which unfortunately leaves lots of room for error. What if we looked at the same problem from a different approach? Students could add up using friendly numbers to find the difference. By adding up in friendly chunks, the same difference can be found. In this example, by simply subtracting 1 from each number, students can keep a constant difference without the need to regroup across zeros. Regardless of the strategy or algorithm used, the most important component is if the strategy used is efficient and makes sense. As stated in the Georgia Standards of Excellence Math Glossary, a standard algorithm is an algorithm based on place value decomposition. The standard algorithm is not exclusive to the U.S. traditional algorithm. Students need to make sense of their learning in context without specific procedures forcing specific steps. For additional support and resources, please visit GeorgiaStandards.Org, where you can access additional task, intervention materials, as well as view the third grade video on adding and subtracting within 1000.